Well, here we're going to look at, back in the old cave of science, we're going to look at wave speed. Oh crap, I got to get the old pen going again here. Let's see if I can find a nice color. There we go. So we're going to look at wave speed. Or, as the case may be, wave velocity. Well, wave speed or velocity is v for velocity equals the frequency times the wavelength, or lambda there. So let's take a look at a couple of these terms here. We know velocity, the standard unit is meters per second. It's meters per second. Wavelength, again, the standard unit in the metric system is going to be in meters. But let's look at this term called frequency. Frequency is the number of, we're going to call them cycles, or waves that pass a given point per second, given point per second. Well, if you think about this, let's say you're standing in the water. You're standing in the water, and you're on the beach, and you've got some waves going by you. You got the shore here, and yada yada yada. Well, as you're standing there, if you were to count the number of waves that go by you per second, or crest if you will, that would be your frequency. And frequency is measured in what's called hertz. You've heard the term frequency, your favorite radio station. You get into megahertz on the FM, kilohertz on the AM, 93.7, 95.7, what have you. And so a hertz is really going to be cycles per second. So let's take a look at the math here. Velocity equals frequency times wavelength. Well, frequency is cycles per second, and that's just really a number, cycles per second, times wavelength, which is in meters. So if you do the math here, you get meters per second. And that is the formula for wave speed. A little bit different than, for an object that is running, but really kind of works the same way here. A lot of times you're going to see this just written as 1 over s, and again times m. It'll give you meters per second. So we can do a quick problem here, if you will. And again, I always like to write the formula. So velocity equals frequency times wavelength. And let's say you've got some type of wave, and we'll be talking about electromagnetic waves just a little bit, probably in the next video or so. So let's say we got a frequency equals 5 hertz. And again, that's the units. Kind of like the rent-a-car, and it's HZ on there. And let's say we have a wavelength of 2 meters, and I think my phone is ringing. So we can go ahead and plug this in. We can get our wave speed. So velocity equals, and 5 hertz Hz times 2 meters, and 5 times 2 is 10, and that is meters per second. So, the algebra is pretty straightforward and fairly simple. One other thing to remember on wave speed, and we're going to spend more time working on we start working on electromagnetic waves, we're going to talk about the speed of light. The speed of light. And you'll be doing some problems with the speed of light. But the speed of light is the fastest anything can go. You know, the speed of light as it goes through a vacuum or the emptiness of space. Speed of light, you know, in the atmosphere going through glass is going to be slower, but the fastest anything you can go, it's the speed of light. You know, unless you're Captain of the Enterprise, you can get her up to warp 10, then who knows, you might be able to get it going a little bit faster. But the speed of light in a vacuum, and V-A-C-U-U, in a vacuum, is 3 times 10 to the 8th meters per second. And that is given the value, or given the symbol of a lowercase c. So anytime you're working with an electromagnetic wave, you quite often will see C equals frequency times wavelength, where this is the constant, or the speed of light, which is 3 times 10 to the 8th meters per second. And that's the, you know, a constant. You know, it's kind of like the acceleration due to gravity. You know, talk about it being a constant 9.81. All right, that's it for this edition, and we'll catch you on the flip side.